So today I am going to talk about interaction picture. So according to Fermi golden rule, and we have studied it in the quantum mechanics. So according to Fermi golden rule, the transition from initial state, that is I, it is represented by ket I, to set of final states F is given by so that means there is a I state and it gives different final states. Say it is F1, F2 and F3. So final state is represented by F, ket F. So then the transition rate, so basically transition rate, right? So the transition rate W is written as 2 pi h cross F h prime I mod square into rho EF. It is given by this one. So let us call it as equation number 1. So this is according to Fermi golden rule. Here F h prime I, it is the matrix element of the perturbation between final and initial states. And rho EF, it is the density of the final states. Density of final states. And rho EF dE, it is the number of final states with energy between E and E plus dE, and here H prime is the perturbed Hamiltonian. And this perturbation is very small. So keeping this Fermi golden rule in mind, so let us consider consider H is equal to h naught plus hi, and here hi is the interaction Hamiltonian. Interaction Hamiltonian causing perturbation. And this perturbation is very small. This we have to keep in mind. So therefore transition rate for state I to f is given as, this is according to equation number 1, so it must be w is equal to, and sometimes it is represented like this, so it is 2 pi rho ef. Here we have not used h cross because h cross is equal to 1, which we have used in the equation number 1, but here we are not using it here because h cross is equal to 1 in natural units. So this equation is according to equation number 1. So I and f are eigenstates of h naught. Now consider time dependent Schrodinger wave equation. Now consider time dependent Schrodinger equation. So it is I d upon dt psi t, this has represent Schrodinger picture, so it is equal to h psi t s, and let us call it as equation number 4. Now we want to transform now we want to transform Schrodinger picture to interaction picture. So for this, let us apply unitary transformation. Let us apply unitary transformation. So that means psi t I, it is equal to I e raised to power iota h naught t psi t s. So this is a unitary transformation which we are using right here. So but we need an equation like this, but in place of s we should have t here. So for that, what should we do? Sorry, I here means we need, using these two equations, we need a equation like this: iota d upon dt psi t I must be equal to h is something else in different form. It should be I. It should be like this. We need a such type of equation. This is not the exact form, but we need a such type of equation using these two. So for that, what should I do? Let us take the time derivative of this one. So if we take time derivative, so if we take a time derivative, then I can write down it as d upon dt psi t I must be equal to d upon dt e raised to power iota h naught t and psi t s, time derivative of this equation number 5. So it is s. So d upon dt psi t I, it must be equal to, we have to apply here product rule. This is first function, this is second function. So derivative of first function is iota h naught e raised to power iota h naught t, and second derivative will remain as it is, plus e raised to power iota h naught t, first function will remain as it is, and then derivative of the second function. So it should be written like this. But if I use equation number 4, so according to equation number 4, this part is equal to, this part is equal to psi t I, right? So therefore you can write down this equation as I h naught psi t I plus e raised to power iota h naught t d upon dt, this one. But if I apply equation number 4, according to equation number 4, this part is equal to, this is from equation 4, so according to that, this is equal to 1 over iota h psi t s, right? So how it can be expressed? So therefore d upon dt psi t I must be equal to I h naught psi t I plus e raised to power iota h naught t e raised to power iota h naught t, and its value will be this one. So it is h over iota into psi t s, right? That's what we are getting. Now multiplying both sides by iota, if we multiply by iota, then what it will be? It is iota d upon dt psi t I, it must be equal to, this will become minus, because iota into iota, iota square is minus 1, so h naught psi t I plus this iota will cancel out, so e raised to power iota h naught t into this one, right? But if I use equation number 5 over this part, so according to equation number 5, this is equal to what? This is equal to e raised to power minus iota h naught t psi t I. So thus this equation will be equal to I d upon dt psi t I is equal to minus h naught psi t I plus e raised to power iota h naught t h e raised to power minus iota h naught t into psi t I. right? So this is the equation. Now this has been transformed into a equation in which psi ts is not sitting. Now let us remodify it. So for this, let us now define, keeping this term in mind, let us define that h naught I t is equal to e raised to power iota h naught t, h naught e raised to power minus iota h naught t, and this is equal to h naught. It should be defined in such a manner. Similarly, hi t can be defined at e raised to power iota h naught t into h naught. Sorry, it is h, not h naught, but it is h e raised to power minus iota h naught t. And let us put the value of h. So e raised to power iota h naught t, it is h naught plus hi, and e raised to power minus iota h naught t, such that if I simplify it, so e raised to power iota h naught t, h naught into minus iota h naught t plus e raised to power iota h naught t and hi into e raised to power minus iota h naught t. We simplified it. As we have defined it in this way, so this makes it is equal to h naught, and this makes it is equal to hi t, right? So therefore this hit, it can be written as h naught plus hit, or you can write down it as like this simply, right? So therefore equation 6 can be written as this is I d upon dt psi t I is equal to minus h naught psi t I plus e raised to power iota h naught t h e raised to power minus iota h naught t and psi t I. So therefore let us put its value. So it is h naught psi t I plus e raised to power iota h naught t h naught plus hi into e raised to power minus iota h naught t to psi t I. So this whole of the part, it simplifies to according to this equation. So it is h naught psi t I, it is e raised to power iota h naught t into h naught e raised to power minus iota h naught t plus e raised to power iota h naught t hi e raised to power minus iota h naught t and psi t I, right? Let me correct it little bit. Yeah, so it is like this. So therefore this is equal to h naught psi t I, and this is h naught, this is multiplied by with it psi t I, then it is plus, it is hi, so it is hi psi t I, and this will cancel out with it because negative sign is here. Yeah, I have forgotten this negative sign, so it should be there. So I d upon dt psi t I. So therefore we are having a equation I d upon dt psi t I it must be equal to hi psi ti. So this is one equation for the interaction picture. Also, let us talk about the another equation for the operator. So similarly, an operator A in Schrodinger picture, operator A in Schrodinger picture related to operator AIT in interaction picture by unitary transformation. So therefore we should write down that A I T, it must be equal to e raised to power iota h naught t A e raised to power minus iota h naught t. So let us call it as equation number 8, and I dAI t over dt must be equal to AIT comma h naught. So equation 7 and 9 are the required equations for interaction picture. So that's all for this lecture, and these equations are also known as equations of motion. So that's all for this lecture.